All right, now graphing rational functions today is what we'll be talking about. This is like graphing inverses. Now we didn't talk about it too much last time, but graphing inverse variations, if you notice the equation, it's y equals k over x. Okay. All right, and if I take a look at that, okay, as if the value of y went up, the value of x has to go down because the k is always going to be constant. And if this number is to get bigger, I'm going to have to divide a plain old number that doesn't change, divide it by a smaller number. Okay, because the smaller you go in the fractions, the better off you're going to be. Now, if I reverse that and this one goes up, in other words, my value in the denominator goes up, then what happens to the end result is that my actual number decreases. So it's an inverse variation relationship because as one increases, the other one decreases. Now, graphing that is a whole lot of fun because you can actually look at tables and actually see the relationship. We'll talk about asymptotes in a sec. Okay, but asymptotes are just graphical way of saying extraneous solutions. Okay, all right, and we're going to use Desmos like no other on this one. Okay, okay, all right. So let's start out with the most basic of them: y equals 1 divided by x. Okay, now the actual graph, the relationship of as x increases, y decreases, or as x decreases, y increases looks like this. So if you'd like to, go to the Edit List button, then convert to a table, and you'll be able to see this relationship. Now the cool thing is if you put your cursor right here next to 2 and press enter, it goes to 3 automatically. If you press it enter again, 4, 5, 6. So some really cool stuff right there. Okay. All right, now that shows the relationship that as x increases, y is decreasing. But how do I show as x decreases that y increases? Well, you have to go into here and press enter and change this to, like, I guess 3/4. Okay, something like that. Some fraction between 0 and 1. So I go back up here and I press enter again, and I'm going to do 1/2. I'm going to press enter again and do maybe 1/3, 1/4. Okay. And as I look at my values, I'm actually able to see that as x decreases, y increases. Okay, which makes total sense because this is an inverse variation relationship. The cool thing is that I can actually see this graphically now and just work with it. Okay. Now, if I were actually to put some other values in there, let's put in, let's go y equals 1 divided by x minus 1. Okay. Now, our normal graph would be y equals 1 divided by x. If you notice, they're a little bit different. I'm going to make them the same color just so that everyone can see them. Black is really, it's nice, but it's not the best in the world to work with. Okay, so our first graph, well, actually making them the same color is not even the best either because that really kind of throws you off. Okay, so our green graph is going to be, let me show you. Our green graph is going to be this one right here. It's going to be the outermost part. And then our blue graph is going to be our original. This is what we call a parent function. Okay, now if you notice, it looks like it shifted over 1. Okay, from the original. All right, now if I also graph at the same time, if I graph x equals 1, okay, if you notice, in my denominator, if I plug in a 1, I'm going to get an undefined function. So I don't want to plug in 1. Okay, so this is what we would call an asymptote, is a line that goes right here and it represents the restrictions on the values of what variables you can plug into here. Okay, now if I change that to another equation, y equals 1 over x plus 3, okay, you can see clearly that I can get that value from this graph. So I would move this over to 0 and voila. I once again have an asymptote of, if I plug this into 0, if I had x as 0, it'd be 1 over 0, which is undefined, which would totally ruin the rest of the problem. Okay? All right, now if I change that to y equals 1 over x minus 4, now let's make that a plus 4. There we go. Okay, obviously I can plug in 4 because, or I can plug in 0 because 0 plus 4 is 4, and 1 divided by 4 is a quarter, so that makes sense why I can do that. But if I move my asymptote over here to negative 4, which is one of my restrictions, I'm going to find again that I have an asymptote. Okay? All right? And because if I plug in a negative 4, I'm going to get 0 on the bottom, and that's a huge issue. So your asymptotes are going to be these imaginary lines that tell you where your restrictions are. How can you find asymptotes? Set the bottom of the rational expression equal to 0, and then you'll be able to solve for x, and that will tell you what the rational asymptotes are. Okay, now this type of asymptote is called a vertical asymptote. Why? Because it goes up and down. It's vertical. Okay, now if I wanted to represent a horizontal asymptote, okay, I can actually use it. I can use y equals that line. So this purple line is actually going to be my horizontal asymptote. Now what does that mean? That means that I can't get 0 for an answer. So a horizontal asymptote represents what possible answers I can't get. The vertical asymptote represents what x's I cannot plug in. Okay. Now is there an easy way to identify this? Yes. What you want to do is you want to look at your vertical asymptote. Okay, if you graph it, you can quickly identify what numbers you cannot plug into that function, but you can also look for the opposite of what's there. That's also a helpful thing. Now, if there's no number out here, or if there's a 0, it's technically a plus 0, that is going to be your, this number out here is going to be your horizontal asymptote. This number in here, the opposite of it is going to be your vertical asymptote, so that's a cool way to actually remember that. Okay, so if we take a look at this one, okay, now obviously I can plug in negative 4, so I'm going to go back to 0 because that's going to be my vertical asymptote. But my horizontal asymptote, I can get 0 as an answer. If I plug in negative 1/3, I am going to get 0. So I need to move this up. Okay, the only answer I can't get is actually 3. Okay, and if you, that does make sense because this would have to be 0 to add with 3, and there's no possible way for this number to be 0. So that's an impossibility. So my horizontal asymptote I find by setting this equal to 0, which is x equals 0, so that makes sense. And my horizontal asymptote, I'm just going to count this part at the end, and that's going to be the positive 3. Okay. Now if I change this to a minus 3, oops, a minus 3, I would definitely need to change my horizontal asymptote down to a negative 3. And voila. Now how do I know I have the asymptote? When I don't have any intersection between the two graphs anymore. Okay. Alright. So that's kind of the beginning parts of it, and this is actually called vertex form and what you guys are using. So as you're using it, just please take time to just type in x equals a number, y equals a number, and mess around with the sliders to see how to get the asymptotes there, okay? Alright. And just remember, when you're graphing, when you're typing in here, remember that the cursor will stay down here until you press right or left to actually get it out, okay? And the only way to get back in is to actually move your mouse in there and click on it, okay? Alright, so that's everything that you're going to need to know about rational graphs right now. Please take advantage of Desmos, and please identify horizontal and vertical, vertical and horizontal asymptotes, either by looking at the graph in its vertex form or actually graphing it and then messing around with the sliders until you get there, okay? Alright, that's it for working with graphing rational expressions. I'll talk to you later. Bye.